Chapter 14, sample problem number 15. Two identical point sources are generating waves with the same frequency and amplitude. That'll be important. But they are out of phase with each other. So the instant one is creating a crest, the other is creating a trough. The wavelength of the waves is equal to the distance between the two sources, which I'm going to also mark to highlight for us. These are our sources. And then we are asked to label all the points where the two sources constructively interfere. And when we're done with that, we're also going to do where they destructively interfere. So our wave generators are doing something like what's been drawn here, where the left one is pulsing one way, and the right one is creating a trough where the other one is creating, right? The right one is creating a trough where the first one's creating a peak. And then vice versa, where this one's creating a trough, this one's creating a peak. So then we can see that the difference between their peaks is 1/2 wavelength. So they're half wavelength out of space, out of sequence in space, as it were. So if we had two paths that took the same distance from one to the other, so let's say if we take, for the moment, let's focus on D, then the distance that this wave travels and the distance that this wave travels is the same. But if that's the case, then wherever this guy is at the opposite value. No matter where we are, the wave of one is negative the wave of the other, so their sum would be 0. That would actually be destructive interference. So we have accidentally found that D is a case of destructive interference. Let's walk through the others and see what happens. So let's take now A. The distance for A here to the wavelength is 1/2 lambda, and the distance to the other one is 3/2 lambda. So the difference in path lengths is 3/2 lambda minus 1/2 lambda, or 1 lambda. But that would still mean that when this guy is maximized, right, one wavelength later for that would be over here, would be adding to this guy. They're off. This is off by 1 wavelength. At each point here is off by 1 wavelength. And what that ends up again is that we're still going to get, they add to 0. So A is also destructive, because what we'll find out is if they differ by a wavelength or a multiple of a wavelength, then we're at the same time in each cycle. But we know that at the same time they have opposite values, so they'll exactly cancel out. All right, let's now do B. For B, we are only 1/4 wavelength. Sorry, that's pretty badly written. Let's try that again. 1/4 lambda, because it's 1/2 of a box, which itself is 1/2 lambda. And then this is a box and a half, so that's 3/4 lambda. So the delta of the path length is 3/4 lambda minus 1/4 lambda, or 1/2 lambda. So that says that whenever this guy is, say, at his peak, it's only a half ahead of the other one. So I go back 1/2 and I say, oh wait, that's also at a peak. And if I take this one, which is at a trough, and I go back half a wavelength, then the right one is behind by that amount. Actually, I guess it's ahead by the amount. But no matter what one I pick, I'm going to find that the half wavelength means I flipped the sign of the other guy. So now we're going to get that their sum is positive. It's something really, it's the amplitude plus the amplitude, really. So this is what we would call constructive interference. That's part B. And for completeness, we might as well finish up C. For C, we're going to have the first guy is, what is that, 3/2 lambda. And the other one is, from here to here, is 5/2 lambda. So the change in path lengths is 5/2 lambda minus 3/2 lambda, which is just lambda, which again was destructive interference. So what we find for these guys is that only B is constructive, and all the others are destructive. And again, to summarize what that means, to be constructive, we need to be at the same place in our cycle, which means normally if they were in phase, we'd say they differed by 1 wavelength. But they're already a half wavelength out of phase, so they have to differ by a half wavelength so as to get to the right place. Destructive is where the two will cancel. If they had been in phase, that would be wherever they were off by the half wavelength. But now we've got to shift that by another half wavelength to be a full wavelength. So the switch of the out of phaseness here makes this a little bit more complicated than it normally would be.